Welcome to Spring LIB.
Okay, so we've got the following. And we need to react this either with potassium cyanate and cyanic acid, or a Grignard reagent, ethyl magnesium chloride, and diethyl ether, followed by aqueous workup. Okay. They also want us to specify stereochemistry. There's not a whole lot of stereochemical information here, and I'll point out why. So rather than use, so this is potassium plus with CN triple bound, and it's a nucleophilic carbon there. Let me draw this a little more clearly. It's a carbon triply bound to a nitrogen with a negative charge on the carbon. Okay, so that's our nucleophile in this case. And that nucleophile is going to attack this electrophilic, partially positive carbon on the carbonyl right there, right? And in the case of the ethyl magnesium chloride, our nucleophile is a negatively charged carbon on an ethyl next to a positively charged magnesium chloride. Right? So our nucleophile is that carbon in the second case. And that nucleophile is going to attack this positively charged carbonyl. Okay? So what I want to point out is that in either case, what we're looking at is a nucleophile attacking this carbonyl. So I'm going to go through using the, I guess we'll just go through both, right? So the first step will be attack on the carbonyl, and the double bond flips up onto the oxygen. Right, so that's the first step in the mechanism. Now, what you'll notice is that this was previously sp2 and therefore planar, and that attack can happen either from the top or the bottom. Right, so we're going to create a tetrahedral intermediate carbon. And this can happen in one of two ways, either to give us the R or S stereochemistry, right? And we'll get an equal mixture of both. So whatever our product is, we're going to get a racemic mixture of R and S, right? Okay, now the second step in this reaction is that we do an aqueous workup, which means we have H3O plus available for this oxygen to come and grab. So we'll get an alcohol. Okay, that's the final step. Okay. In case of the potassium cyanate, it's going to be very similar, right? But because we are in a protic solvent, we're actually this is going to proceed a little bit different. Right, so we're in acidic medium. Remember, the HCN is a fairly strong acid. And when we've got acids around carbonyls, one of the first things we see is their protonation. Okay? And here's kind of an optional step to show how electrophilic this carbon is that we often show a resonance structure in which the double bond hops up onto the oxygen to relieve the positive charge and place the positive charge on the carbon, creating a carbocation. In either case, we, just as in last time, we have a planar carbon, which is what our negatively charged carbon is going to be attracted to. Nucleophilic attack on the electrophilic carbon. generating a tetrahedral intermediate, or in this case, a tetrahedral product. Really, we're done here. This is the final product. Okay, that's the same idea in both cases. It's attack on an electrophilic carbon, and it proceeds. The attack happens while the carbon is sp2, so when we're done, we're going to get a racemic mixture of R and S products, right? So we could draw it like half of it's going to look like this. And the other half will look like this. And it'll be in 50-50. And the same is true here.